In exercise 306, we turn our focus now to volume and surface area, in particular of a cylinder. So again, curved surface, you'll need to recall formulas to do with circles that we've just dealt with in 303 and apply those to both surface area and volume. Now, most of you will have come across these concepts before, and again, I encourage you to work through this exercise having your formula sheet beside you and seeing which formulas are there and the ones that you have to learn. The volume of a cylinder is calculated using the formula pi r squared h, and volume is always measured in units cubed. I'll go through these examples with you and hope you'll be able to get started straight on the questions out of this exercise. It says, calculate the volume of cake in the following, given the diameter is 25 and has height 8 centimetres. We're going to practice good approach to solving problems by underlining and identifying. I'll pause the video and do that and come back and talk about it. So you can see there that I've underlined calculate and I've replaced it with find. We should always identify what the question's asking, and in this case the word calculate tells me what I'm finding, and it is calculate the volume. So highlight that volume of cake in the following, given the diameter is 25 and the height is 8. Obviously we underline those, they're the numbers, that's the data, that's the information that's given. When I look at this shape, I recognise this shape as a cylinder, so if I'm finding the volume, which I've actually written down now, I'm identifying what I have highlighted and underlined. I'm identifying it. I'm rewriting it. You may think that's an unnecessary step, but it's actually not. It's showing the marker that you can get the information out of the worded question, and that is really important that you show the marker this. And then if you think about that, you're finding the volume, you'll know, and you recognise the shape as cylinder, you will write the formula V equals pi r squared h. Now have a think about that formula. It's got 1, 2, 3 unknowns. Pi is not an unknown. Pi is a number stored on your calculator. Given a formula with 3 unknowns, you could be asked to find or calculate any one of those 3 unknowns. This question in particular is asking you to find the V. The V is the subject of this formula, so this is a nice, easy sort of question. We know that the diameter is 25, and I've written diameter is 25, and the height is 8. Now, having either thought about it or actually rewriting the formula to get started, and again, this is a really important thing to do. Why? Because it gives me a pattern to follow. I'm finding V, no problem. Pi is a number. However, at this stage I say, oh, the pattern says I've got to find the radius. I've got to substitute a value for r. I didn't come across r anywhere in the question. Where is the r? Well, now we go back to what information was given. We were given that the diameter is 25. So from that, we can establish that the radius is only half, which is 12.5. It's all these little things that you really have to be registering. Don't take anything for granted. Don't think that you'll always just be given the value of the concept that you need. This is an example where you weren't. You need R, you weren't given R, but you were given the information to calculate R. Keep that in mind. So we've got pi times 12.5, which needs to be squared and multiplied by the height, which is 8. Then take your calculator, and I'll pause the video and get the calculator up on screen and put that in. So you can see there the answer is 3926.9908.7. The only problem for me is that the moment I attempt to write that here, the calculator goes to the background and I can't see it anymore. So I'll just leave that on there and you can jot that number down. It doesn't give any rounding instructions. You know that the answer would be centimetres cubed. Okay, as you can see then in the next part, that should be part 2, it says calculate the percentage increase in volume if the radius is doubled. Now if you haven't done your underlining, then you can pause the video, do your underlining and then come back and have a look at what I've done. Calculate, underline it, that tells us what we're finding. That tells me what I'm finding. You should start somewhere in your solution with, or you should have somewhere in the start, the beginning of your solution, what you are actually finding, as well as the other information given in the question. So calculate the percentage increase. You can see I've written find percentage increase. What sort of things are coming to mind when you see percentage? Hopefully percentage, before you can get a percentage, you must have a fraction. These things that'll have to come to mind automatically. No, you're not going to be prompted through the question to find the fraction. You're not going to be prompted through the question to find the increase in volume. You have to read these words and comprehend what they mean. An increase in volume? There was my previous volume. How do I know what the volume has increased to? What does that suggest? That then suggests that I've got to find a new volume. How will I find a new volume? I'll find a new volume using this piece of information that I've been given, that is that the radius is doubled. The radius is double. What does that mean the radius is equal to? It was equal to 12.5. Now the radius has to go to 25. So what do I have to do? I've got to find a new volume. I've got to find, the increase then in volume. I've got to write this as a fraction. I've got to turn this then into a percentage. There's lots to do in this question, and you won't be stepped through it. You won't be told, find the new volume, find the increase, write this as a fraction, convert it to a percentage. All you're simply asked to do is calculate the percentage increase. Now, my advice to you is pause the video, set yourself to work on that. When you're happy that you've got an answer, come back, restart the video and see if your answer agrees with mine. Okay, so calculated the volume with the doubled radius from 12.5 to 25. I've found the increase as the difference between this 15,000 and the previous nearly 4,000, 3,900, and that difference was 11,000. I made my fraction out of that, 11, the increase over what it was originally. The increase is much bigger than what it was initially. Multiplied that by 100 and got a 300% increase. Hopefully you've got that answer as well. Moving on then to the concept of surface area. We need to consider both an open and a closed cylinder. Now, some of you will know from stage 5 that when we're talking about area, we're talking about the shapes that make this solid. And for a cylinder, it's made of a rectangle and 2 circles. So this is the top, the bottom, and this is the circular bit that gets folded around and makes, altogether, all 3 surfaces make the cylinder. Now, If we've got an open cylinder, then we don't have one of these circles, and in fact you may in some cases not have either. If you thought about a hose, the garden hose with the water coming out of it, you will realise that a hose doesn't have either of the circles. It only consists of this curved surface. The water needs to be able to get in one end and out the other. So if we were talking about the surface area of a hose, we wouldn't be considering either of the circles, and we would only be required to use this 2 pi RH. A glass tumbler or a vase with a flower in it is sometimes considered to be open. It's open on one end so that we can fit the flower in the vase, but it does have one circular shape creating the bottom of the vase, and so we would need one of these pi r squareds. So the amount of glass needed to make this would be your 2 pi RH plus one circle only, pi r squared, the area of the circular base. It's important that you understand the difference between opened and closed cylinders, and in doing that you need to develop an understanding of what these aspects of the formula are representing. Circles, 2 circles, and this is the curved surface part only. I'll do these examples with you in class, but you should be able to get started on some of the easier questions out of 306.